Hello everyone, welcome to the YouTube channel of YourPedia Engineering Credit Point. So I am Vinny Sharma, your mentor of mechanical engineering. So basically in this video I am going to solve the previous year analysis of previous year question paper of the BEL Probationary Engineer. As you know, the BEL has announced the vacancy of probationary engineer in which the mechanical and electronics aspirants are eligible. Okay, so there are around 200 vacancies of the electronic engineers and 150 vacancies of the mechanical engineering. Okay, so it is a very nice opportunities for all the aspirants for all over the India. Okay, so just prepare it for very well and clear this exam. Okay, so before delaying any further, let us start with the previous year paper solutions. So before starting the previous year paper solutions, I am going to analyze some previous data. Okay, I am going to tell you that how many which subject is more relevant for you. Okay, and specifically in which subject do you need to do focus. So see here, if we do the simple paper analysis of the BEL Probationary Officer 2023 exam, specifically of 2023. So in this case, if you see, there are around total number of questions are there 125. Okay, in which the general aptitude consists of 12 questions and the remaining reasoning portion, the reasoning is of 13. Reasoning comprises of the 13 questions here. Okay, so if you see, out of 120 questions, the total 25 questions are basically from the non-technical part, and the remaining 100 questions are from the technical part here. And in the technical part also, the majorly asked subject is the machine design, industrial engineering, theory of machine, thermal portion, okay, as well as the strength of material. Okay, so these are some of the subject which are very important as per the previous year exam. Okay, so in this case, if we see, the strength of material and the machine design, both of these subjects are related to the engineering mechanics. Okay, and it comprises of total 16 plus 14, that is 30 questions are directly being asked from the mechanics part. And similarly, if we talk about the thermal part, the thermal part consists of around 9 question, 5, 9, and then we have a 3, 3, 1. Okay, so these are the some of the number of questions which can be asked from the thermal engineering part. Okay, so if you see, there are total around 18 plus 23, 23 plus 20, around again 30 questions are asked from the thermal engineering part. Okay, so that means if we do the previous analysis of the BEL exam, so out of 125 questions, 25 questions are directly related to your non-technical part. Okay, it is consist of non-technical part, and specifically around 30 questions are related to the mechanics portion. Okay, on an average 30 question more or less, and similarly around 30 question has been asked from the thermal engineering part, including fluid mechanics, fluid machinery, heat transfer. Okay, I am talking about the basic thermodynamics, along with that applied thermodynamics. And the remaining portion, if you see, remaining 10 questions, okay, not 10 questions actually, it is around 60 plus 85, around your 35 questions are directly being asked from the production engineering, production plus material science plus your industrial part. Okay, so whenever you have start preparing the BEL exam, so you have to majorly focus on this part. The first one is the mechanics portion, then you have to have a look on the thermal portion, and then you have a look on the other part, that is production, MS and industrial engineering. So all of these three parts constituting the around 30%. Okay, so just remember that. So this is the previous year analysis, and I am going to solve as many questions of all of these subjects. Okay, and along with that, some of the questions will be taken by the Rajiv sir also. Okay, so let us start with the first question of the previous year exam. So see, in the first question of the exam, this question is basically asked from the theory of machine, specifically the topic from the balancing part. Okay, this question is related to the balancing part here, balancing topic of the theory of machine. So what has been asked in this question? In the dynamics of a machine, unbalanced forces due to the reciprocating machines can mostly lead to. See, basically when we talk about any engine, whether it is a 2-stroke engine or 4-stroke engine, there are some components which constitute of the rotating mass, as well as there are some component which constitutes the reciprocating masses. Okay, so the balancing of the rotating mass is very simple. You can easily balance the entire rotating mass, but the balancing of the reciprocating mass, it is very difficult. You cannot control, you cannot balance the entire reciprocating mass. In that case, what do we have to do? We have to balance some portion of the reciprocating mass, okay, and the remaining unbalanced portion of the reciprocating mass basically lead to the vibration in the system. So the vibration which is occurring in the system is due to the only the reciprocating masses which has been left unbalanced, okay, just remember that. Okay, so that's a very simple question, and if you calculate the value of the unbalanced forces, the unbalanced forces can be calculated by this particular formula, mr omega square cos of theta plus cos 2 theta by n. So these are the unbalanced forces which are caused due to the reciprocating masses, in which the first part is known as the primary forces, primary unbalanced forces here. And similarly, if you see the other part, mr omega square cos of 2 theta by n, it basically consists of the secondary forces here. Okay, so if we talk about the unbalanced forces, the total unbalanced force comprises of the primary plus secondary forces, out of which the primary has a major portion, okay, has a major, or I can say significant effect on the vibration of the machines. Okay, just remember that the effect of the secondary forces are very negligible as compared to the primary forces. So that is why it is very important to balance this in primary forces, and if the secondary forces are not balanced or it remain unbalanced, so then it won't create any much problem, okay, like the primary forces. Just remember that. So now let's move to our next part. For one-dimensional steady state heat conduction through a plane wall without heat generation and with the constant thermal conductivity, which of the following statement is true? So you have been asked to mark the true statement regarding the steady state heat conduction. Now what is the meaning of steady state heat conduction? So let us suppose if you have a wall which is maintained at a temperature of T1 here, and this side is maintained at a temperature of T2, and the heat is flowing in this direction. Let us say the magnitude of the heat is Q. In that case, if you see, there are certain assumptions taken while the analysis of this particular problem. Okay, so here we use the Fourier law of heat conduction to solve this problem, and in that case the first assumption which we take is the steady state heat conduction. Now what is the meaning of steady state heat conduction? Steady state means the amount of heat which is being entered into the wall is equal to the amount of heat which is being rejected from the wall. Okay, so if I define a element here, then the Q1 is representing the amount of heat which is being entered into the element, and the corresponding Q2 is representing the amount of heat which is being rejected from the element. Okay, so under the steady state condition, this Q1 and Q2 is going to be remain same. Just remember that. Okay, because if this condition is not maintained, in that case what will happen? The temperature of the surfaces will change with respect to the time, and the steady state means the properties of the system is not changing with respect to time here. Okay, so that is the first assumption, that is it is the steady state heat conduction. Second assumption you take is that there is a heat transfer in one direction only. The third assumption you take, the surfaces are isothermal. Now what is the meaning of isothermal surfaces here? Isothermal surfaces means the surfaces, the temperature of this surface remain constant. Okay, with time it is not going to be changed. For example, if the left side of the wall is maintained at a temperature of T1, in that case the temperature T1 is going to be remain same. It is not going to change from T1 to T2, from T2 to T3. If the temperature remains change, then it will come under the steady state condition. If the temperature continuously changes, then it will fall under the category of the unsteady state heat transfer. Okay, just remember that. So here I can say, first, the temperature distribution is linear. That is true. The temperature remain constant across the wall. It is wrong. The temperature is not maintained across the wall here. If you see across the wall, the temperature is being reduced because the heat transfer required the temperature gradient in order to flow. Okay, how you define the heat? Heat is basically a mode of heat transfer, is a mode of energy transfer which take place due to the temperature difference from high to low temperature. Okay, so high temperature to low temperature is the required condition to the heat flow. Just remember that. Next, the temperature increases exponential across the wall. That is also a wrong statement. The next, the temperature distribution is exponential. That is also wrong. So the statement number A is the correct answer of this question. Okay, so the next question is, while analyzing the acceleration of a point in a rotating link using the relative acceleration equation, which component is not directly considered? Which component is not directly considered? Okay, so see here, so that's a very simple question which has been asked from the theory of machine part, from the acceleration analysis of a mechanism. So here let us suppose if you have an element which is a rotating element and it is rotating at about point O. Okay, and if I take a point, let us say point number A here. Okay, so there is a point number A, and this link is rotating with the angular velocity omega. So here if I assume that if the angular velocity of the link is constant, in that case the angular acceleration will be 0, and if the angular velocity of the link is not constant, it is continuously changing. Okay, for example during the starting and during the stopping of the fan. Okay, at that point of time we can say there will be some angular acceleration acting over the link. Okay, so now what happens actually here, whenever you do the analysis of any point on a rotating link, there are two acceleration which are there. Okay, the first one is the radial acceleration, which is always going to be there whether the link rotates with a constant angular velocity or whether the link rotates with the varying angular velocity. Just remember that. And the value of the radial acceleration will be v square upon r, or I can say omega square r. Okay, just remember that. And along with that, if the link is rotating with the varying angular velocity, in that case we are going to have a angular acceleration, and due to the angular acceleration we are going to observe the tangential acceleration here, whose magnitude can be calculated by the r into alpha product. Okay, just remember that. So here I can say during the rotation of the link, tangential acceleration is there, your centripetal acceleration is there. Centripetal acceleration is nothing but the radial acceleration. Next, if there is some other portion, some other part is there, let us say here we have a slider, let us say slider B, and if the slider is moving in the vertical direction with respect to the rotating link, okay, with a velocity v, in that case we have an additional component of acceleration which is known as the coriolis acceleration. Okay, so the magnitude of the coriolis acceleration can be written as 2 into velocity of slider multiplied by angular velocity of the link. Okay, and how do you define the direction of coriolis acceleration? What you have to do, you have to just rotate the angular, you just have to rotate the velocity vector in the same direction of the omega by 90 degree. Okay, so let us suppose if the angular velocity is in the clockwise direction, so just rotate the velocity vector by 90 degree in the clockwise direction. So if I rotate the velocity vector in the by 90 degree in the direction of omega, we will find the direction of the coriolis acceleration. Okay, so just remember that. So that means we have a coriolis acceleration also inside the rotating link. Okay, so now here the only option, that is gravitational acceleration, is left here. So gravitational acceleration is going to be the correct answer of this question, because you have to mark the option which is not directly considered in the analysis here. Okay, so just remember that. So now the next question is, for a closed system undergoing a process between the two specified state, the decrease in availability of the system. Okay, so now just see what is the meaning of availability. Availability is defined as the maximum useful energy which can be extracted from the heat. So if you see, the heat is basically a low grade energy which comprises of the available energy plus unavailable part. Okay, so this available energy can be converted into the high grade energy, or I can say work. Okay, if the heat is allowed to expand till the dead state. Okay, and similarly the unavailable part is going to be rejected to the sink here. Okay, so just remember, whenever in the question you have been asked to calculate the decrease in availability, in that case the decrease in availability will result into the corresponding increase in the unavailability. Why so? Let us understand in this way. Suppose if you have an engine, let us say a hypothetical engine is there and it is operating between the temperature limit of 1000 and 300 Kelvin. Okay, and if you see, let us say if you are supplying the heat of 1000 kilojoule here, 1000 kilojoule, and if I ask you that what will be the maximum amount of work which you can extract from this system, so you can simply say, sir, the maximum efficiency of this system is going to be equal to 1 minus 300 by 1000, that is 0.7. So that means the maximum work which you can extract from this engine will be 700 kilojoule. Okay, and the remaining 300 kilojoule is going to be rejected. It is going to be rejected. So I can say this maximum work 700 is going to be the available energy, and similarly the 300 is going to be represent the unavailable part if the system is expanding up to the dead state, if the heat is expanding up to the dead state here. So in that case, let us say now the engine is not a perfectly reversible one, okay, and I am saying if you are supplying heat of 1000 kilojoule, then the corresponding amount of work which is being produced is equal to 500 kilojoule, let us say. Then the corresponding unavailability, the corresponding unavailable energy will be 500. Okay, so if you just analyze it very carefully, previously we have a available energy of 700, now we have a available energy of 500. So how much decrement of available energy is there? That is of 200 kilojoule, 700 minus 500. And correspondingly, if I ask you that what will be the increment in the unavailable part of energy, so here you can see initially the unavailable part is 300, but now the unavailable part is 500. So I can say there is an increment of 200 kilojoule in the unavailability. Okay, so that means the decrease in availability is basically is equal to the increase in unavailability of the system. Okay, so just remember that. So in any question, if they ask you to calculate the value of the decrease in availability, just remember it is asking you to calculate the value of increase in unavailability also, increase in unavailability also, and the increase in unavailability is known as the irreversibility. Okay, so it is also known as the irreversibility. Okay, just remember that, which can be calculated by the theorem, Gauss-Todler theorem, okay, which tells you about the rate of increase of irreversibility is equal to the dead state temperature multiplied by the rate of entropy generation. Okay, just remember that. So here the option number C is going to be the correct answer of this question. Next question, the critical radius of insulation for a cylindrical object like a pipe is the radius. So that's a very simple question related to the heat transfer. We already know that the critical radius of insulation is the radius at which the maximum amount of heat transfer take place, okay, and the corresponding radius is very, very minimum. Okay, so let us say if you have a pipe here, okay, and let us say this is the radius R1, and I am assuming this radius R is below the critical radius, and here the corresponding amount of heat loss from this wire is Q. So here you can see the point number 1 can be located here. So now as soon as you are increasing the radius, initially we observe experimentally that there is an increment in the heat transfer up to a certain radius. After that, the corresponding heat transfer decreases with the increase in radius. So the radius at which the corresponding amount of heat transfer is very high is known as the critical radius of insulation. Okay, just remember that. And corresponding to this point, the total resistance of the system is minimum. Okay, so here I can say the critical radius of insulation is the radius at which the heat transfer rate is maximized. Okay, so option number B is going to be the correct answer of this question. Next part, the instantaneous center of zero velocity for a moving rigid body in a planar motion is. Okay, so now just see what is the meaning of instantaneous center. So first of all, just see it is asking you about the center. Now what is the meaning of center here? Actually what happens whenever you do the analysis of any mechanism, okay, so if you see generally we have a general motion. It is neither the pure rotation, it is neither the pure translation. Okay, it is basically a combination of rotational motion as well as the translation motion. In that case, it is very difficult to analyze those mechanisms. Okay, so there we use the instantaneous center for analyzing those mechanisms here. So now how do we define the instantaneous center? Instantaneous center is a imaginary point which always keep on changing, okay, about which we assume that the body is at its body is under the pure rotation at that particular instant of time. Just remember this. For example, let us say there is some road, it is moving, it is having a motion of something like that. Here I am assuming that the link is having this particular motion. Okay, so here you can see it is neither the pure rotation and it is neither the pure translation. So how do we analyze this type of link here? So in that case, what we do here, we define at some imaginary point. Let us say this is an imaginary point O, about which we are assuming that this link is under the pure rotation at that particular instant. Okay, and if you remember, let us say if this is a wheel and if it is rotating with a constant angular velocity, and if I find out the velocity vector of this particular point A. So just remember, how do we find out the velocity vector? We just create a line between this O point and the A point and the O point, and we draw a perpendicular normal to this line. So this perpendicular line is representing the velocity vector. Okay, so here I can say if any link is having a pure rotation, in that case the velocity vector is always perpendicular to the line joining the A point and the O point. Okay, so whenever you are finding the instantaneous center, you have to make sure that the velocity of a particular point is making a perpendicular line with this particular velocity vector. Okay, just remember that. So in that case, if you see, let us suppose if you have a simple wheel, let us say we have a simple wheel and it is purely rotating about this point O, okay, with some angular velocity omega. So if I ask you that where will be the instantaneous center, so just think about it, that about which point it is basically purely rotating. So we can say this is purely rotating about point number O. Okay, so this O point is nothing but it is the instantaneous center. So this is going to be the instantaneous center of this particular wheel. Okay, similarly, let us say we have another wheel which is purely rotating. Along with that, it is also translating on a wheel, translating on a flat surface. In that case, where will be the instantaneous center? Okay, so in that case, what you have to do, just have 2 points. Let us say we have one point here, B point, and we have another point A here. So if you see, the A and B are going to have one velocity component in the horizontal direction because both of these points are translating toward the right side. Okay, along with that, this wheel is basically rotating and this point A and B are lying on the wheel. So I can say the velocity of B is going to be like this one. Oh, sorry. So here you see the velocity of B is going to be something like that. Okay, due to the pure rotation. And similarly, due to the pure rotation, the velocity of the point A is going to be like that. So if I take the resultant of these two velocities, you will find this one and this one by using the parallelogram law of vector addition. So here in that case, in order to find out the instantaneous center, what you have to do, you have to create a perpendicular line from this velocity direction. Okay, so if you draw a perpendicular line, so if you see, these perpendicular lines are intersecting at this particular point I. Okay, so this I point is representing the instantaneous center. Here we can assume this entire wheel is having a pure rotation at this particular I point. Okay, so as soon as the wheel changes its position, the corresponding instantaneous center will also get changed. Okay, so just remember that. So here I can say the instantaneous center is a point about which the body seems to rotate at that particular instant. Okay, so option number D will be the correct answer. Next, in a rotational flow of an incompressible fluid, which component of acceleration is always 0? So again, the question has been asked from the fluid mechanics. Okay, so in that case, if you see, it is asking you about the rotational flow. Okay, so just remember, whenever the fluid is having a rotary motion, in that case, always the radial acceleration will be there. Okay, so radial acceleration will be always there. And here, whenever we are defining the accelerations, generally the acceleration of particles, the total acceleration of particle constitutes two types of acceleration. The first one is known as the local acceleration, which is due to the change of velocity with respect to the time. Along with that, we have a convective acceleration. So here the convective acceleration is due to the change in velocity with respect to the space. So I can say in the rotational flow, we have a radial acceleration, along with that centripetal acceleration, along with that convective acceleration, because the velocity change is going to be there with respect to the space. Okay, but the tangential acceleration is not required here. Why so? Tangential acceleration will be there only whenever the fluid is having a unsteady motion, or whenever the fluid is rotating with the varying angular velocity. In that case, we are going to have a tangential acceleration, which is having a product of radial which is having a product of radius as well as the angular acceleration. Okay, so just remember that. So here the option number D will be the correct answer. Next question. Surge in a centrifugal compressor is a phenomena that can occur. Okay, so just remember that in the case of compressor there are two different points. One is known as the surging and the other point is known as the choking. Now what is the meaning of choking? So first of all, just see, choking represents the condition where the maximum mass flow rate through the compressor occur, okay, which correspond to the Mach number 1. Whereas the surging tells you about the minimum mass flow rate which can be passed through the compressor. As soon as you decrease the mass flow rate below the surge limit, what will happen? The breakdown or the flow reversal will take place over the blade profile. Okay, so just remember, whenever you plot a graph between the mass flow rate and the pressure ratio, the graph will be plotted like this one here. Okay, so here the mass flow rate corresponding to the maximum pressure rise, this point number 1 is represent the surge point. Okay, so basically the point number 1 signifies the minimum mass flow rate which can be passed through the compressor, and similarly the maximum mass flow rate correspond to the Mach number 1. Okay, why so? Because if the Mach number is greater than 1, in that case there can be a chances of the generation of pressure waves or shock waves here. Okay, so this point number 2 represents the choke limit here. Okay, so just remember this. So here I can say surge in a centrifugal compressor is basically a phenomena that can occur when the flow rate of the gas is reduced below the critical value. Option number A is going to be the correct answer of this question. Okay, chalo. Now the next question is, for a real gas, the van der Waals equation of a state introduced the correction factor for both the volume and the pressure of gas. The correction of volume is due to the, okay, so now just see, first of all, generally in thermodynamics we deal with the two type of gases. The first one is known as the ideal gases and the second one is known as the real gases here. So here the ideal gas follow the van der Waals, ideal gas equation, which can be written as PV is equal to mRT, or we can write PV is equal to nR bar T. And similarly the real gas follows the van der Waals equation, which is the experimental formula given by this particular equation. Okay, so in that case the A and B are basically the constant which are introduced. Okay, so here the A accounts for the cohesion forces between the molecules, whereas the B accounts for the finite volume of the gas molecules. Because in the case of ideal gas we assume it is a perfectly compressible gas, but in the case of real gases it is not perfectly compressible. Okay, so in order to account that incompressibility, we have defined this parameter B here. Okay, so it represents the finite volume of the gas molecule. Just remember that. Next question. The Rankine cycle efficiency can be improved with the use of superheating. Okay, which of the following statement is not a reason for this improvement here? Okay, so here if you see the option, the first option, it increases the latent heat of vaporization of the working fluid, it is completely wrong, because the latent heat of vaporization does not changes due to the superheating, whether reheating or subcooling or by any effect. Okay, with the increase in pressure it always decreases, but at a constant pressure it always remain constant, whether you do superheating or whether you do subcooling here. So option number A is going to be the correct answer. So here the next question is, in a diesel cycle, if both the compression ratio and the cutoff ratio are increased while keeping all the other parameter constant, what happened to the cycle thermal efficiency? See, in the case of diesel cycle, the efficiency can be calculated by this particular relation. Okay, where R is known as the compression ratio, which is basically a ratio of the total volume divided by clearance volume, and correspondingly the rho is defined as the cutoff ratio, that is volume before expansion. I can write, if you create a simple diesel cycle here, the cutoff ratio is basically a ratio of V3 by V2 here. Okay, volume before expansion, that is divided by volume after compression here. Okay, so if you see, if you increase the compression ratio, the corresponding efficiency will increase, but if you increase the cutoff ratio, the corresponding efficiency will decrease. But if you see the net effect of the cutoff ratio is more as compared to the compression ratio, so we can say if the cutoff ratio is increased, the corresponding efficiency of a diesel cycle will reduce. So the option number D is going to be the correct answer of this question. Okay. Next question is, which dimensionless number is widely used in the forced convection heat transfer and to decide on the type of flow as laminar or turbulent? So just remember, in the case of forced convection, we normally study the Nusselt number, which is a function of Reynolds number and Prandtl number, and here we also have a free convection where we study the again three number, that is Nusselt number, which is a product of Grashof number and Prandtl number. Okay, and the product of Grashof and Prandtl number is known as the Rayleigh number here. So in case of forced convection, whether the flow is laminar or turbulent, it depends upon the value of the Reynolds number here. In the case of free convection, whether the flow is laminar or turbulent, it depends upon the Rayleigh number. So if the value of the Rayleigh number is more than 10 to the power 9, the flow is known as the turbulent flow, and if the value of the Rayleigh number is less than 10 to the power 9, we define it as a laminar flow. Just remember this. Okay, so here I can say the option number A is going to be the correct answer. Next question, one way to reduce the peak pressure in a diesel engine without altering the overall compression ratio. Okay, so now just see, in the case of diesel engine, how the compression takes place. First of all, the air enters into the cylinder which is getting compressed. After that, we supply the fuel into the system. Okay, and due to the high temperature of the compressed air, the combustion of the fuel takes place. Okay, so now what happens, let us say if you introduce the fuel earlier in the compression process, what will happen? There will be a sufficient time for the diesel to mix up with the air. Okay, so we can say the combustion of the diesel fuel will be get delayed, due to which the peak pressure can be reduced. Okay, so just remember this. So option number A is going to be the correct answer here. Next part, in an axial flow compressor, the primary flow direction of the working fluid, that is very simple question, parallel to the axis of rotation. In the case of centrifugal compressor, the fluid always flows in the radial direction. Okay, just remember that. Or in the case of reciprocating compressor, the rise in pressure is basically occurring due to the decrease in volume, that is the positively displacement pump compressors. Next, the Dietz-Boelter equation used for calculating the Nusselt number for turbulent flow is given by this particular relation. Okay, for heating of fluid, and what are the values of M and N respectively. Just remember, in the case of laminar flow, the relationship of between the Nusselt number, Reynolds number and Prandtl number is written as like this one. Okay, so here you have to remember that this is the value of the local Nusselt number, and if you similarly calculate the value of the average Nusselt number, the formula will become this one here. Okay, and specifically when we talk about the turbulent flow, in that case the Nusselt number formula is 0.023, Reynolds number 4/5, Prandtl number 1/3. So I can say the value of M is 0.8 and the value of N is 0.33. Okay, so the option number B is going to be the correct answer of this question. Next part, the Buckingham-Pai theorem in the dimension analysis states that if the physical process involves n variable and k fundamental dimensions, the number of dimensionless group. So now just see, in the case of dimensional analysis, generally we use two types of method. The first one is known as the Buckingham-Pai theorem and the second one is known as the Rayleigh method. Okay, the Rayleigh method is basically used whenever the number of variables used in the analysis are up to 4 or 5. But if the unknown variables become more than 5, in that case the Rayleigh number fails to establish the particular relation. So in that case we have to define the Buckingham-Pai theorem. Okay, so in the case of Buckingham-Pai theorem, it tells you if there are n total number of variables including dependent and independent. Okay, and correspondingly these n variables have k fundamental dimensions. In that case we can find out some we can define some dimensionless parameters, which is known as the pi terms. Okay, we can arrange the parameters, we can arrange the variables in such a way that it forms a dimensionless group. Okay, and which that dimensionless group is known as the pi terms here. So basically the number of pi terms are equal to n minus k. Okay, so just remember this. Option number A is going to be the correct answer of this question. Next part, the Prandtl number is very crucial in understanding the relative growth of the hydrodynamics and correspondingly thermal boundary layer. When the Prandtl number is more than 1, then which of the following statement is true? Okay, so whenever you are doing the question like this, just remember, just pay attention that whether they are going to ask you the true statements or the false statement. Okay, just remember this. So here if you see, the Prandtl number is basically a ratio of the kinematic viscosity to the thermal diffusivity, which can be further written as the ratio of the hydrodynamic boundary layer to the thermal boundary layer. Okay, or which can be written as mu Cp by K. So if the value of the Prandtl number is more than 1, it signifies that the value of the delta is greater than the delta T. Okay, so I can say the rate of growth of the hydrodynamic boundary layer is more as compared to the thermal boundary layer. So option number D is going to be the correct answer. So next part is, under which of the following condition does a real gas mostly behave like an ideal gas? That's a very simple question. So whenever you make the pressure very low and corresponding temperature is very high, the real gas approaches the behavior of the ideal gases here. So option number C is going to be the correct answer. Next, for a system with multiple particles, the D'Alembert principle can be applied to. Okay, so now just see, the D'Alembert principle is basically used in order to convert the dynamic unbalanced problem into the dynamic equilibrium case. Okay, so how do we define it? Let us suppose there is a body on which number of forces are acting on it. Okay, F1, F2 and F3. So due to this number of forces, what is happening? The body is moving with some particular acceleration A. Okay, so that means I can say, according to the Newton's second law of motion, when the number of forces are acting, the rate of change of momentum is occurring here, and due to the rate of change of momentum, the net force is acting on the body, which is equal to the mass into acceleration here. Okay, so now the analysis of this particular body is very difficult. So what we do, we add a pseudo force or an imaginary or hypothetical force over it in such a way the net forces will become equal to 0, and that imaginary or pseudo force is known as the inertia forces. Okay, so if you see, according to the D'Alembert principle, the net forces acting over the body, including the inertia forces, are going to be equal to 0. Okay, so from this conclusion, from this we can also conclude that the inertia force is having a magnitude of mass into acceleration. It is always acting opposite to the direction of the net forces. Okay, just remember this. So now in that case, it is asking, for a system with multiple particles, the D'Alembert principle can be applied. So now just remember, whenever we are dealing with the multiple particles, the D'Alembert principle can be applied whether to the whole of the body or whether to or either to the each and every particles of the body. Okay, so here I can write then option number A is going to be the correct answer. Next question, the BEL cycle commonly used for the air refrigeration operates on the principle. That's a very simple question. BEL cycle is the opposite of the reverse Brayton cycle, and it is also known as the reverse Brayton cycle here. And this cycle consists of two isobaric processes of heat addition and heat rejection, and also it constitutes two isentropic processes in which there is no heat rejection or heat addition is taking place. Next, how does increasing the thermal conductivity of a fin material affect its overall heat transfer coefficient, overall heat transfer performance? So just see, to check whether the overall heat transfer performance of a fin, we have to look at the fin effectiveness parameter. And the fin effectiveness, how do we define the fin effectiveness? Fin effectiveness tells you that whether the use of fin is good or not. Okay, so let us suppose if you have a surface. Okay, so if you want to enhance the heat transfer, you can use a fin over it. Okay, but we are not sure that whether the use of fin will enhance the heat transfer or not. Okay, so in order to find out this, we need to calculate the value of the fin effectiveness. So fin effectiveness is defined as the ratio of heat transfer with fin divided by heat transfer without fin. So if the value of the effectiveness is more than 1, then the use of the fin is justifiable. Okay, just remember this one. And similarly, if we find out the expression of the effectiveness of the fin, its relation is Pk upon Ha. That means the effectiveness is directly proportional to the thermal conductivity, it is inversely proportional to the heat transfer coefficient, and it is directly proportional to the P by A ratio. So if the thermal conductivity of the material is increased, the performance of the fin will get improved. If the heat transfer coefficient increases, in that case the corresponding effectiveness will decrease. That is why the fins are always used in those conditions where the heat transfer coefficient is very low, because at the low heat transfer coefficient condition the effectiveness is going to be more. Okay, similarly the fins are always be designed in such a way that the P by A ratio of the fin should be very high. If the ratio is very high, in that case the corresponding value of the effectiveness will get improved. Okay, so here I can say with the increasing thermal conductivity the heat transfer rate increases from the fin here. Next question, the primary unbalanced force of reciprocating mass is usually counteracted by. Okay, so just remember in the first question I have told you that the engine consists of reciprocating masses as well as the rotating masses. Okay, so basically the rotating masses are completely balanced by some balanced masses here, but the complete balancing of reciprocating masses is not possible. Why not? Because if you try to balance the entire reciprocating masses, there will be some hammer blow effect, okay, which is due to the balanced mass here. So generally what we do, in order to balance the reciprocating mass, we generally balance the 2/3 of the total reciprocating mass here. Okay, and how do we balance it? We generally balance the reciprocating masses by providing the masses on the rotating shaft here. Okay, let us suppose if you have a piston here, and here we have a connecting rod, and here we have a crank. So what we do, we generally, let us suppose if it is having a mass of m here. Okay, the reciprocating mass is m here. So in order to balance this mass, we generally provide a balanced mass here. So this balanced mass is provided opposite to the crank here. Okay, or I can say it is provided on the rotating shaft. Okay, so just remember this one. So here I can say it can be provided, it can be counteracted by balancing weights on the rotating shafts here. Okay, just remember this one. You cannot distribute the reciprocating masses evenly around the axis of rotation. This is not a way of balancing the reciprocating mass. Okay, it is a way of balancing the rotating masses here. The balancing does not depend upon the engine speed, even though the unbalancing depends upon the engine speed. With the increasing speed, the balancing does not get changed, but the unbalanced force will get increased. Okay, and by damper you are basically reducing the vibration, not the reciprocating masses here. Next, in an isochoric process, what is the relationship between the heat transfer and change in internal energy? So just see here, according to the first law of thermodynamics, Q is equal to delta U plus W. Okay, and in the case of isochoric process, the constant volume process, the work done is going to be 0. That means all the heat supplied into the system increases the internal energy of the system here. So the option number A is going to be the correct answer. Next part, in a laminar flow over a flat plate, how does the thermal layer thickness delta T varies with respect to the distance x from the leading edge? In that case, just remember, from the Prandtl number we say that boundary layer thickness is directly proportional to the thermal boundary layer thickness. Okay, and also the hydrodynamic boundary layer thickness can be calculated by this particular relation. So here if you see, if you simplify this particular expression, you will find that the delta is directly proportional to the x by 1/2 here. Okay, so with the increase in the distance from the leading edge, the corresponding boundary layer thickness is going to be increased, and similarly we can say the hydrodynamic boundary layer thickness is also increasing. That is thermal boundary layer thickness is also increasing with respect to the length of the plate here. So option number A is going to be the correct answer. Next part, in which type of gear arrangement is the axis of the two shafts neither parallel nor intersecting? That is a very simple question. Hypoid gears are there, okay, or hyperboloid gears are there. Next, a free body diagram is a representation. So see here, this question is basically asked from the engineering mechanics. And what is the meaning of free body diagram? Free body diagram is a representation in such a way that we separate each and every part of the body with the other parts, and we show each and every force which is acting on the body here. Okay, so basically it illustrates all the forces acting on the body, including the gravitational forces. Next part, for a floating body in equilibrium, the meta-center. See here, basically the meta-center concept arises in the only the floating bodies part. Okay, in the case of submerged body, we don't have a concept of meta-center. Okay, so now how do we define the stability here? First of all, the metacentric height, which is defined by the gm, the distance between the metacenter point and the center of gravity. If the value of the metacentric height is basically positive, we define it is a stable condition. Okay, just remember this one. Similarly, if the metacentric height value is 0, that means it is a neutral condition. And along with that, if the metacentric height value is negative, it is a unstable condition. Okay. So now what is the formula of the metacentric height? Actually, metacentric height is basically defined as the I by V bar minus Bg here. So under this stable condition, the metacenter always lies above the center of gravity as well as the center of buoyancy here. Okay, so here the option number B is going to be the correct answer. The metacenter always lies above the center of gravity and the center of buoyancy here. Next part, a system undergoes a cyclic processes and return to its initial state. Which of the following state is true regarding this process? Okay, so now just see, if the system is undergoing a cyclic processes and return to its initial state, that means a thermodynamic cycle has been established. Okay, in that case, the change in point function, whether it's a change in pressure, change in temperature, change in volume, change in internal energy, it is always going to be 0. So we can say in that case, from the first law of thermodynamics, the net heat supplied into the system is going to be equal to the net work output from the system here. Okay, so now here I can write the change in internal energy of the system is going to be 0 because it is a point function. Okay, and the initial and final states are same. The internal energy is a point function here. The work done by the system is 0. It is not 0 here because all the heat is getting, which is being added into the system, is directly going to convert into the work done here. Okay, and vice versa. Next, which of the following component is not typically found in a basic heat pump cycle? So out of these, the combustion chamber is not a part of heat pump cycle because combustion chamber is a portion in which you burn some fuel in order to raise the pressure and temperature here. So option number C is going to be the correct, is the wrong option here. Next, a lamina is said to be in rotational equilibrium. Under the rotational equilibrium, there will be no forces or there will be no torque or moment acting on the body here. So option number B is going to be the correct answer here. Next part, in the context of fin, the fin efficiency is defined as the ratio of. Okay, so now just see. Basically, in the case of fins, we normally define two types of parameters. The first one is known as the fin efficiency. Fin efficiency, and the other portion is known as the fin effectiveness. Fin effectiveness here. So now in that case, how do we define the fin efficiency here? Fin efficiency is basically a ratio of the actual heat transfer which is being out from the fin here to the maximum possible heat transfer rate from the fin. Okay, so fin efficiency is defined as the ratio of the actual heat transfer which is taking place from the fin divided by the maximum possible heat transfer which can take place from the fin. And how do you calculate the maximum possible heat transfer? In order to calculate the maximum possible heat transfer, you assume that the temperature of the entire fin is maintained at the root temperature. Okay, but in practical scenario it is not possible because as soon as the heat is basically transferring, the corresponding temperature gradient will be there. Okay, so just remember this one. So the next part is fin effectiveness. Just right now I have told you the fin effectiveness is basically a ratio of the actual heat transfer with fin, divided by heat transfer without fin. So it tells you whether the use of fin is justifiable or not. Okay. Next part is the train value N2 by N1 is equal to T2 by T1. That's a very simple question. It is directly asked from the simple gear train, related to the simple gear train. Next, the isochronous governor has a characteristic curves. So now just see, whenever you are studying the governor, there are three conditions. The first one is the isochronism, then the other one is the stable one, and the other one are the unstable one. So if we plot a graph between the controlling force and the radius of the governor, here the isochronism governor is always shown like this one, and the equation of this particular line is written as F is equal to A of R. Okay. Similarly, if you see the graph of unstable governor is basically this one here. whose equation is AR plus B. Okay, and similarly if you write the equation of stable governor, the equation will be F is equal to AR minus B. Okay, so just remember this. Here the first curve is representing the unstable governor, the second one is representing the isochronous governor, and the third one is representing the stable governor here. Okay, so here the option C will be the correct answer here. Okay, in this case. Next part, in the Otto cycle, the compression and expansion process are theoretically modeled as, that's a very simple part, adiabatic process, and the heat addition take place at isochloric process. Okay, and the heat rejection take place at a isochoric process. Similarly, in the case of diesel cycle, the heat transfer take place, heat addition take place at a constant pressure process, and the heat rejection take place at a constant volume process. Okay, and the compression and expansion is always shown by the adiabatic processes. Next, the Grashof number is used in a natural convection problem. It relates which of the following? See, basically the Grashof number is a number which is frequently used in the free convection. Okay, and the product of Grashof and Prandtl number is basically a Rayleigh number which tells you about whether the flow is laminar or turbulent. So in that case, the Grashof number is a number which basically compares the buoyancy forces with respect to the viscous forces. Okay, so if the value of Grashof number is very high, so we can say that the effect of buoyancy is very much high as compared to the viscous forces. Okay, so here the option number D is going to be the correct answer. Next part, the compressibility factor Z for an ideal gas. See, the compressibility factor is defined as the ratio of PV by RT. So it tells you how the real gases are different from the ideal gases. Okay, so if the value of the compressibility factor is 1, in that case we can say the real gases has approached the ideal gas behavior here. Okay, so in that case, for an ideal gas, the value of the compressibility factor is equal to the 1 here. Okay, just remember this one. Next part, which type of gear is used to transmit the motion between the non-coplanar, non-intersecting, non-parallel shaft here? Okay, which type of gear is used to transmit the motion between non-coplanar, non-intersecting, non-parallel shaft? So that means you are going to use hypoid gears or the hyperboloid gear. Okay, so here in this case we can say the herringbone gears are used. Okay, just remember this one. Next part, in a 4-bar linkage, the Grashof criteria states that for at least one link to be capable of making a complete revolution with respect to its adjacent link, which condition must be met? So see here, in the case of 4-bar mechanism, okay, there are different types of inversions. Okay, whether you have a double crank, then you have a crank rocker, and then you have a double rocker. Okay, so these are the some of the inversions which can be there in the case of 4-bar mechanism. So these inversion can be created if the mechanism is satisfying the Grashof conditions. And what is the meaning of Grashof condition? Grashof law, basically Grashof criteria states that if the sum of the smallest link of this entire link plus the sum of the smallest and the longest link is basically less than or equal to the sum of the length of other two links, in that case we can say the Grashof criteria is satisfied and we can have a different types of inversion. We can produce different types of inversion there. Let us suppose if this condition is not met, okay, if this condition is not verified, in that case you are always going to have only one type of inversion, that will be double rocker. Okay, so in order to have one complete rotation of a mechanism, one complete rotation of a link of a mechanism, in that case this Grashof condition has to be satisfied. Okay, so just remember this one. So what is S here? S is the length of the smallest link. Okay, L is the length of the longest link, and P and Q are represent the length of the other two links. Okay, so in that case the option number D is going to be the correct answer. Okay, S plus L should be less than or equal to P plus Q here. Next part, convective acceleration in a fluid dynamics. I've already told you it is due to the rate of change of velocity with respect to the space coordinates. That means the spatial variation in velocity along the flow directions. Next part, consider a system subjected to an external force F and an inertia pseudo force Fi. The essence of D'Alembert principle is best captured by which of the following statements? The system is in dynamic equilibrium when F plus Fi is equal to 0. ये correct है बिल्कुल आपके पास, that is correct, that is a correct statement. The inertia force acts to oppose the action of the external force, that is also correct. Okay, that is why the body is coming into the dynamic equilibrium state. Next, the system is in equilibrium when the F is equal to Fi, that is also correct. Okay, I have already explained you that when the net forces is equal to the inertia force, which is also equal to the mass into acceleration, then the net forces will become equal to 0 and the body will be in the equilibrium condition. Okay, the next part is the difference of the internal force and inertia force on the system is always 0, that is also correct. Okay, but out of these four statements, the basic condition of the essence of the D'Alembert principle is captured by the first statement here, because this is the initial point which I explained you during the D'Alembert principle. Okay, just remember this one. Next part, which of the following best describe an isobaric process in a closed system? That's a very simple question. During an isobaric process, the pressure of the system remain always constant. Next part, in an adiabatic process, which of the following is true regarding the relationship between W and change in internal energy? So now again, from the first law of thermodynamics, you can write Q is equal to delta U plus W. So if the process is adiabatic, in that case Q will be 0 and the work is going to be equal to delta U. Okay, so the option number D is going to be the correct answer here. Next part, the Rayleigh number in the free convection scenario is essential to predict the onset of the turbulence. Which of the following dimensionless group is represented by the Rayleigh number? So I have already explained many times that Rayleigh number is basically a product of Grashof number and Prandtl number. Option number C is going to be the correct answer. Next part, the velocity ratio of which gear train can be determined by the method, tabular method and the algebraic method here. Okay, so just remember, the tabular method or algebraic methods are used in those gear train where the axis of one of the gear is also having a relative motion. Okay, and this case is always there in case of epicyclic gear train. Okay, so option number C is going to be the correct option here. So now just see, these are some of the question which I have covered right now. Okay, and the remaining question will be covered by the Rajiv sir. Okay, so he will continue with the 45th question. Okay, so now you can see in this all the questions, all the theoretical portion is being asked. Okay, and the questions are very direct. Okay, they are not very difficult, but you should have a very deep knowledge of all of these topics, because if you don't have a sufficient knowledge, that then they make maybe there are chances that it will be some maybe you will find this question very tricky. Okay, so just make sure that you prepare your subjects very thoroughly. Okay, and you should have a very good theoretical knowledge about each and every topic from your subject. Okay, so that's the only message which I want to give you. So from the 45th question, the Rajiv sir will continue. Okay, and you can also see we have already started the classes. Okay, the batch has already been started from the 15th of January. Okay, and the thermodynamics and engineering mechanics has also been started here, so you can also join the module. Okay, from the link which is being provided in the below this particular video. Okay, so now I'm providing this board to the Rajiv sir, and he will continue with the other questions.
Yes, hello my dear friends. So let's start with the question number 45. Before earlier that we have seen initial 44th question has been taken by the Binit sir. So now let's start with all these questions. Basically we will deal about the production, material science and SOM and FM, all these type of question I am going to deal here. So that is the next question, 45 question on the screen. The question is that the lower deviation of a hole is 0, right, and the minimum limit of the hole size is the basic size. This type of shaft is basically basic hole, shaft basic system, hole basic system and basic shaft. So yes my dear friends, since we can see here lower deviation is 0, that means they are going to talk about the what my dear friends, we can say this is the hole basic system. In hole basic system, you know, here one more thing is given, minimum limit of the hole size is the basic size. That means minimum is fixed, so it will be the what, hole basic system. So that was the basic questions, and obviously that question has been taken from the metrology and inspection. Basically there are two types, hole basic system, shaft basic system. So from that question has been taken from that one. So let's start with another question. Next question is that which of the following is a heat treatment process? They are talking about the heat treatment process, right? Primarily used to relieve the internal stress in the material. When you are going to be doing the heat treatment, so what's happened? Generally there is a huge amount of thermal stress is going to be developed. So, and especially if you are going to fast cooling rate, again same issue is going to arise. So to remove that type of issue, what you have to perform? You have to perform the annealing operation. What you are going to do in the annealing operation? You are going to heat, and after that you are going to cool it in the ambient air, right? So not a fast cooling, it is a slow cooling, and then you can be able to relieve the internal stresses. So that process is called basically annealing. Annealing is the major process to relieve the internal stresses, especially thermal stresses. Come to the next question. So that is your next question. In a cooling curve of pure metal, obviously that question is also taken from the material science. The plateau represent first the temperature at which the metal is fully solid, the latent heat of fusion, the time taken for the complete solidification, and option D, the temperature range where both solid and liquid phase coexist. So if you go through the cooling curve, my dear friends, then you will find basically cooling curve represent the temperature range over which both the solid and liquid phase is going to be coexist. So the correct answer will be the D for Delhi, or you can say 4 is the right answer. Come to the next question. So the question is that a cantilever beam subjected to uniformly distributed load, UDL is there, along entire length, will have maximum bending moment at option A at the fixed end, option B 1/4 span from the free end at the free end, option D the mid span. So obviously if you talk about cantilever beam, maximum amount of bending moment is going to generate at the what, my dear friends? Fixed end. And whenever you are going to talk about the cantilever beam, so maximum amount, suppose this one, so like that, and there is a UDL, uniformly distributed load, na? This is something like that. So maximum amount of bending moment is going to develop here. If they will try to rotate in that direction, it will develop in that direction, and that will be the maximum there. So we can say maximum will develop at the fixed end. Now next question is that while designing a shaft of a fluctuating load, the primary consideration prevent the fatigue failure is, basically that question has been taken from the design of machine element, or you can say machine design. More precisely if you talk about the topic, then that topic has been taken from the design against fatigue load, right? So the question is that here fluctuating load is there, right? That means that is a fatigue load. And when you talk about the fatigue load, the main designing criteria that you have to be considered, that will be the endurance limit. Basically the endurance limit will be the very impact, sometimes 0.45, sometimes 0.5, sometimes 0.9 times of their yield strength, right? And always endurance limit will be less than that of yield strength. So when you are going to design, especially in the fluctuating load or fatigue load, if you talk, then in the designing parameter you have to consider the endurance limit, because that is not going to the permanent deformation. It will fail very before to the yield point. So you have to be keep in mind the endurance limit is the major concern here. What is the endurance limit, my dear friends? So we can say it is the maximum, it is that value of maximum stress for which it can complete infinite number of cycles without any failure. That maximum load over which it can complete the maximum number of cycles without any failure, that is known as what? Your endurance limit. Obviously if you increase the load, obviously the life will be decreases, right? Now come to the next question. So my dear friends, that question has been taken from the production engineering, topic is casting. The question is that which casting process involve creating a wax pattern, right, which is subsequently surrounded by a ceramic slurry to form the mold. So a cell will be known permanent die mold casting, sand casting. It is what? Investment casting. In the class I used to say that in case of investment casting you have to be keep in mind wax pattern is going to use. Another thing, sometimes the question is going to ask what is investment casting? You know, investment, it is talk about something money, right? So if you have to make the jewelry, you have to make the ornaments, so for that purpose you are going to use the investment casting. From their name it's very investment, like gold is obviously costly, it is so investment is there, right? Investment word. So from the investment you can understand here wax is going to be used, and here to give the sufficient amount of strength, yes, ceramic slurry is also going to use in case of investment casting. So the correct answer is what? C for Chennai is the right answer. Now the next question is that for a dynamic load, which of the following welded joint type preferred due to the superior fatigue resistance? Yes, again that question has been taken from the machine design, or you can say design of machine element, or you can say machine design. From that particular topic, that question has been taken. You know, here if you talk about the dynamic load, what do you mean by dynamic load? Dynamic load is that load in which case the magnitude of load as well as direction both can change. Either load will change, either direction will change, or if both are going to be changed, then such type of load is known as what? Your dynamic load. Either load can be from 5 Newton to 10 Newton, even sometimes it is going to be compressive, sometimes it is going to be tensile, like that. So direction also change. So whenever if you are going to use the welded joint, especially in case of dynamic load, then ज़्यादा so more superior will be the what? Butt weld. Butt weld is the butt joint, you know now. One is fillet, sport and seam weld. So out of which butt weld is more superior, more stronger, especially in the dynamic load. Now that is the next question. Question is that in CPM analysis, total fluid, CPM, obviously that question has been taken from the industrial engineering. CPM and PERT is subtopic is there. CPM basically exists for the critical path method and PERT is exists for the project evaluation and review technique. Right, so here CPM is there, so critical path method. So the term is total fluid. What the total fluid indicate? If you talk about CPM, what the total fluid indicate, my dear friends? Option A, difference between the earliest start and finish time, non-critical activity, that's not. Time, shape, performing activity in a parallel, no. Buffer added to the project to account uncertainty in activity duration, that is the basically maximum time and activity can be delayed without doing the project completion time or completion date, whatever. So a total float is that time, my dear friends. Suppose total float is 5 days, let's assume. That means you have 5 day buffer time. If you are going to take 5 day, then no issue is there. But if you take, you are going to, in fact we can say you can delay activity by 5 days. Still your project will not get any effect, it will not get delayed. But if you are starting taking any activity more than that one, which is especially on the critical path, then your project will be the project time will be increases. So that is basically total float indicator. So total float, you can say you have a extra time that you can utilize to start any activity, or you can take a rest meanwhile. But if you are going to be taking rest more than that, then your whole project will get delayed. So that is the maximum time and activity can be delayed without delaying the project completion time or date, whatever. So coming to the next question. The next question, this is on your screen, my dear friends. The question is that which of the following output is a typical MRP system? Okay, so this is service part requirement, inventory status, file, bill of material, planned order, schedule. So MRP, if you talk, basically this is what? Planned order and schedule. Next one, knuckle pin are classified as which type of sliding contact bearing motion? Oscillating. So knuckle pin, have you seen knuckle pin? The use of knuckle pin. So knuckle pin can oscillate it like that. It can oscillate. So the correct answer will be the first one is the correct answer. It is going to be oscillate. Knuckle pin classified as sliding contact bearing motion, and they will like do something like that, oscillate. That's why it is called as what? Oscillating. This is not centrifugal, not reciprocating. So it is oscillate. Next one, which of the following is a thrust bearing? Which of the following is a thrust bearing? Yes, this question has been further taken from the design of machine element, or you can say machine design. From that particular topic, that question has been taken. Especially if you talk about subtopic, then obviously that has been taken from the bearing, and they are going to talk about the thrust bearing. So partial journal bearing, thrust bearing is basically collar bearing is the type of thrust bearing. How it is going to happen? Suppose this is your shaft and you are going to use the multiple collar. You can use the multiple collars according to your requirement, like that. So this is called is what, my dear friends? Collars, and basically this is known as collar. So it will be called is what? Collar bearing. So 2 is the right answer. Collar bearing is the correct answer. Basically they are going to provide, suppose if the collar is not going to use, if any force, axial force is acting, it can come inside that, but if there is a collar, they will not allow to move in this axial direction. That is the advantage of collar bearing. The next question is that if two cylindrical shafts are made of the same material and have the same length, but one shaft has twice the diameter of the other, by what factor the torsional stiffness of the larger shaft greater than the smaller one? So my dear friends, that question has been taken from the, you can say, strength of material. So here we can say two cylindrical shaft, this one is one of the cylindrical shaft and that one is another cylindrical shaft. Two cylindrical shafts are made of the same material, have same length, that means both have same length, right, but one shaft has twice diameter. Let's assume if this is D1, so this is D1, this is D2, D2 equal to twice of D1, that is given in the question, right. Now diameter of the other, what factor is the torsional stiffness? Torsional stiffness T by J they are going to talk. So it will be 2 to power 4, that means directly it will be the 16. If you are going to by power 4, it will be what, 16. Easily you will get the option is what, 16. Now that is the next question. The question is that in the designing of shaft, the pressure of cleavage, hole or other notches can introduce stress concentration. What is the typical method to compensate of these stress concentration? How you can compensate these stress concentration, right? So increasing the shaft diameter proportionally to the notch depth, applying surface treatment notch region. Next, introducing fillet and root of notches using material with higher elasticity. So what is the stress concentration? So whenever there is a sudden change in profile is observed, then we can expect there is a stress concentration, right. Suppose this is the your profile and if you are going to apply the load, no stress concentration will coming to be out there, no stress concentration. But suppose this is something like that, okay, and now I am going to apply load that F, I am going to apply. If I will ask from which section it will fail, then obviously we can say from that section. Why? Because from there to there profile is everywhere same, but as you reach at that point, let's assume that is point A, so sudden profile change is going to be takes place, sudden profile change. So here stress will get concentrate over in that area, and that phenomena is known as what? Basically stress concentration factor. That means stress is concentrate. So to reduce that, sometimes local yielding is also going to be happen, especially if you talk about the statics loading is there and material is ductile, then local yielding going to be takes place. So you can do like that. So if you have to be typical to reduce that stress concentration, so you can introduce the fillet at the root of notches. By this you can compensate that stress concentration. Next, for a given column material and cross sectional shape, if length of the column is double the clipping load. So my dear friends, that question has been taken from the strength of material. So obviously if we talk about subtopic, then from the name it's very clear, column, right. So cross sectional area shape, if length of column is double, then the clipping load is reduced to 1/4. It will be reduces to what, my dear friends? It will be reduced to 1/4. That is next question. Which phase of steel in magnetic and have body centered cubic structure BCC? Which phase of steel? Yes, that question has been taken from the material science. And if you talk about topic, then iron carbide diagram, from that one this question has been taken. Which phase of steel is magnetic as well as BCC structures? So if you talk about BCC structures, then it will be what? Ferrite. Ferrite will have BCC as well have magnetic in the nature also. So the correct answer will be the B for Bombay is the right answer. Next, during the simplex method, that is further question has been taken from the CPM and PERT, industrial engineering. The topic is simplex method. When can tendency occur and what is the amplification? It occurs when pivot element cannot be found, loading to not feasible solution. It occurs when there is no constraint leading to unlimited solution. Right. Option third, it occurs when basic variable coefficient becomes 0, possibly leading to the cycling. Fourth one, it occurs when all coefficients in the objective function rho are negative, indicating optimality. So my dear friends, if you talk about simplex method, right, so when can degency occur? What is its amplification? So it occurs when basic variable coefficient becomes 0, then you can find it is going to be degency is going to be occur, even possibly leading to the cycling. So the correct answer will be the C for Chennai. Next question, which of the following property of engineering material describe total amount of energy that a material can absorb before the fracture? Obviously that is well aware question, so you can say toughness. So what is this? Suppose this is any material on which you are going to apply the load, especially load is going to be applied. If you are going to see there, force and deflection diagram is there, so it is going to be like that, something from that one. So whatever energy is stored in that one, whatever energy is stored before the fracture, that is basically nothing but it is called is what? Toughness. So correct answer will be the what, my dear friends? Toughness will be the right answer. So toughness is basically it is an energy absorbed by a body before the fracture point, or maximum amount that they can also absorb before the fracture is known as your toughness. Next question, now for a given material and shaft geometry, which factor primarily affect the torsional stiffness? Yield strength? No. Yield? No, obviously. Ultimate tensile modulus of elasticity? The correct answer is modulus of rigidity. Modulus of rigidity is going to be primary which affect the torsional stiffness will be the modulus of rigidity. That means you are going to talk about the G. T by J, have you remember? G theta by L, right? From that you will get that one. Next question. Question is that which end condition for a column result in shortest effective length and hence the highest critical buckling load when one end and other is free, when one is fixed, other is free, both end are pinned, and one end is pinned and other one is free, both end is fixed. So my dear friends, here see there, column result the shortest effective length. When we will get the shortest effective length? Shortest effective length, obviously when both the end will be what, my dear friends? When both the end will be fixed, then you will get the shortest, then only you are going to get the shortest effective length. So the correct answer will be the D for Delhi. When both ends are fixed, in such case effective length will be the minimum, right? You can comment when you will get the maximum effective length. So there is three options, which one we can choose, you can make a comment here. Next one, in ultrasonic machining, USM, in ultrasonic machining, which type of transducer is used? Electrostatic, high power sine wave, piezoelectric and semi quartz. So what will be the answer, my dear friends? The correct answer is what? Piezoelectric. What do you mean by piezoelectric? So piezoelectric, basically piezoelectric crystal is that type of crystal which is basically going to convert the mechanical energy into the electrical energy. That type of structure or crystal is known as what? Piezoelectric crystal, right? So the question, if you talk about USM, ultrasonic machining, so transducer which is going to use, that is basically piezoelectric. They are going to convert the mechanical energy in the what? Electrical energy. So that is the, you can say, ultrasonic machining. Obviously that is the NDT, non-destructive testing machine. If we talk about an ultrasound, when the, we can say, the frequency is more than 20 kilohertz or more than 20,000 hertz, then it is called ultrasound. Next question, which type of casting is best suited for producing intrinsic design and detailed pattern in mass production? So when you have to be going through the mass production, in such case you are going to use the die casting, right? So in impact you can get the any intricate design which will be very difficult. You have to make a die accordingly, and then for the mass production easily we can go with the die casting process. Next question, Cherepanov rule relate the solidification time of casting to the surface area of the casting only. No. The ratio of square volume of casting to surface area, the ratio of volume of casting to, yes, V upon A. That one is the right answer. Obviously there is a square, but no square is there. The typically LY is used. So the correct answer will be, my dear friends, here the ratio of the volume of casting to its surface area. Next question, in the context of the virtual work principle in the continuum mechanics, which of the following statement is true about a system in equilibrium? That question has been taken from the engineering mechanics. If you talk about topic name, then obviously from the virtual work. So if you talk about virtual work, so in virtual work both conservative and non-conservative force can do work. Both conservative as well as non-conservative force can work in case of what virtual work. Even that work is considered as a virtually. At the last stage, what I am going to make it as a 0. So the correct answer will be A for apple is the right answer. Next, a material that can be drawn into wire under the tension without breaking is said to have, yes, that is known as ductility. So ductility is the property of material because or virtue of which we can draw it in the form of wire. In fact, if the question is going to ask which one material have the highest ductility, metal especially if you talk, then gold is the metal having highest ductility. Approximate, by 1 gram of gold you can draw a 2.4 meter of 2.4 kilometer of the wire. Just take a 1 gram of gold and you can draw 2.5, or sometimes you can say 2.4 kilometer of long wire. So in fact that have the highest ductility of the gold. So ductility, that property, because of that we can convert the material into the wire forms. Next question, in a centrifugal clutch, yeah, that question has been further taken from the design of machine element or machine design. As engine speed increases, the contact force between the clutch, shoes and drum increases due to centrifugal force. So if you talk about centrifugal clutch, so you might have aware this is something like that, that have different types of shoes is there. That shoes can be different types of shoes. That shoes are there, that can be okay, and that one is your drum. So when they will start rotating at the very high RPM, they will come in the contact, that one, they will come in the contact, they will come in the contact, and ultimately from driver, this one is your driven, this one is driven, this one is your driver. So from driver to driven power is get transmitted, right? So in centrifugal casting, so here as increases due to the centrifugal force. So you can say the contact force, that contact force is increasing because of increase due to the centrifugal force, and centrifugal force will increase when it will start at a very high RPM. Especially this type of clutch to going to use where initial power is requirement to high to start. Otherwise directly if they will come in the contact with the driven, might be possible your engine going to be shut off. It is going to be shut down, more precisely we can say. So this is going to be used where low power machine is there. So after getting a certain RPM, they are capable to they are going to become in the contact with that one, then power is going to transmit. So meanwhile they have gained the more energy, so it will not going to be shut down. So that type of clutch is going to use. If you talk about Mayport, in this centrifugal clutch is going to be used. Now a material has modulus of elasticity E, bulk modulus K, and the relation is going to ask. So E equal to I have usually used to say E equal to 3K into 1 minus 2 mu. E equal to what, my dear friends? 3K into 1 minus 2 mu. E equal to sometimes 2G into 1 plus mu. So that all are relation that you have to be also keep in mind. So right, the correct answer will be though B for Bombay is the right answer. Next the question is that given data set with the odd number of observations symmetrically distributed, which of the following statement true? Given a data set with odd number of observation that is symmetrically distributed, which of the following statement is true? The medium is always at the midpoint of the range. The mode is always greater than the medium. The mean is always greater than the medium. The mean, medium and mode all are equal. So in such case, all is going to be what, my dear friends? So odd number observation, then all R will be the equal. Either if we talk about mean, medium or mode, all R is going to be equal. Now if you have section, a truss, and have a 3 unknown forces, which of the following set of equation would most likely not use to find all of them? So that is the option: summation of fx equal to 0, summation of fy and this, summation of x fy this, moment about a b c, not going to be used, right? A b z c. So if you have a sectional truss and have 3 unknown member force, which of the following set of equation would you most likely not use? I am not going to use that one. In such case, if you go through the stress, then I am not going to use all that equation: summation of x equal to 0, summation of fy equal to 0, and summation of y, because you have to take now, if you go through the statics equation. So basically we can say one is summation of all the force is equal to 0, second one summation of all the force in y direction 0, summation of all the force in z direction 0, and yes, moment must be 0 at a given point. So if you see in option 3, not talking about the movement, they are just only talk about the forces. So I am not going to use it. If you are going to make only force balance, if the moment is not balanced, then it will not come in the equilibrium, right? So for the equilibrium, obviously force as well as movement both must be balanced, right? So by keeping that thing in your mind, we can say the C is the wrong answer. So that would not likely to be used. So obviously I am not going to use that one. So according to that, the correct answer is C is the right answer according to that, because I am not going to use that one. Now next question: which of the following is not valid assumption while analyzing bending stress in a beam using Euler-Bernoulli beam theory? So if you have gone through the assumption of this one, then you might have remember the not valid question is that which of the following is not a valid assumption while analyzing bending stresses in beam using Euler. Not valid. So stress strain relationship is linear, that is valid. The beam is subjected to axial stress only. No, that one was not the assumption of that one, right? That one not the assumption of the Euler-Bernoulli beam theory. So the correct answer will be the B for Bombay, or you can say 2 is the right answer. Simply you can get that one. Clear? Come to the next one. Next question is that for a riveted joint where a primary concern is sharing of rivet, which of the following rivet material proportional to the most critical: shear strength, creep resistance, tensile fatigue, and this. So then you can say you have to use the shear strength. You might have remember basically though first one is primary shear force P and second one is secondary shear force. These two are shear force. One is primary shear force, that is basically F upon N, number of rivets, and secondary shear force you are going to choose in such a way that net movement will be the 0. That will make net force is equal to 0, and action of this primary force will be opposite to the applied force, and their movement will be opposite to the applied movement, right? So I am going to talk about the shear strength. That is the most critical that you have to be keep in mind. Next question, three identical beams are connected in parallel. Well, if the total deflection experienced by the system under load P is total deflection is that, which of the following relation is true considering this one is the deflection of one beam? So here beam are connected in a parallel, right? Beam is going to be connected in the parallel. So if the beam is connected in the parallel, then we can say deformation will equal to all, right? So that will be the correct answer will be B for Bombay. No, because that is in the parallel, but yes, if it will be in the series, then deflection we can get all of that. By adding all of that, I am get the total deflection. But in the series connection, so all have equal, the correct answer will be B for Bombay. Next one, in which of the following brake system is a braking action achieved by storing the kinetic energy of the vehicles that can later be reused? Drum brake, disc brake, band brake, and what? Regenerative brake. So what will be answer, my dear friends, here? What will be the answer? So we can say in such case I am going to use what? Regenerative brake. Action achieved by storing the kinetic energy of the vehicle that can be later be reused. That type of brake is known as what? Regenerative brake. There are various type of brake like drum brake, disc brake, band brake, shoe brake, all are there. Regenerative brake. So in such case you are going to use the regenerative brake. Next question, for a fully reverse loading condition, the ascent diagram, the mean stress is, okay, fully reverse, right? Fully reverse, then it will be the 0. Mean if you talk about fully, like sigma 1 is what? 50. So sigma 2 is what? Minus 50, right? Minus 50. This is kilopascal. Let's assume this one is also kilopascal. So what is sigma mean? Sigma mean is sigma 1 plus sigma 2 upon 2, right? So this one is 50 minus 50 upon 2, ultimately you are going to get the 0. So in case of fully reverse bending, the ascent diagram, the mean stress will be always it will be the 0. Always it will be the 0, right? So the correct answer will be the D for Delhi is the right answer. Next question, identify one of the reciprocating sliding contact bearing motion element. So one is crank pin, valve stem, rocker arm, or next one is what? Piston pins. So what will be there, my dear friends? So if you are reciprocating sliding contact bearing, then valve stem have that type of motion, right? So correct answer will be B. Crank pin don't is the right answer here. Next, a set of data consists of the distance positive integral if the mean of the data set to 10 and the standard deviation is 0. Which of the following could be true? First one, one of the value is 50, all the value of data are 10, the medium is 5, the range of the data is greater than. See, a set of data consists of 5 distance positive integral. Distance positive integral if the mean of the data is 10 and the standard deviation is 0. Which of the following is true? So here we can say the mean is basically 10 and even standard deviation is 0, means there is no any deviation. That means all value r is equal to 10, then only there is no any deviation is there. If there is a deviation, all value will not be equal, right? So in the question it clearly mentioned no deviation is there, right? So the correct answer will be the B for Bombay, all value, that means all the value have same 10. Next question, when designing for a dynamic loading, the Goodman line is used to predict failure. Again, that question has been further taken from the machine design, and from the dynamic loading, Goodman, Soderbergh, all these equations going to use. So when designing for the dynamic loading, the Goodman line is used to predict failure by accounting for both mean and alternating stresses. The Goodman line can be most accurately described a linear decreasing line in the mean stress versus alternating stress plot. Yes, that one is only right answer, my dear friends. So if you go through the Goodman, so this is coming something like a linear line. One is Gerber parabola. So parabola is coming to be something like that, right? So where they are talking about the Goodman. So basically this is the linear decreasing, that is not a parabolic horizontal line, that is not a vertical line, that one also. So it is linear decreasing line for mean. Here this is decreasing line, you can see there. So the correct answer will be the A for apple is the right answer. Next, consider the composite bar made of steel and brass. Okay, fixed at both the end. If assemble is heated, which of the following statement true regarding the thermal stresses? Brass will develop higher thermal stresses because it has higher coefficient of thermal expansion than steel. Yes, my dear friends, brass have alpha brass is more than alpha of steel. Alpha of steel, you know. And if you talk about thermal stress, alpha delta T, you are going to get alpha delta T and A. If alpha is more, obviously they have more. So brass will have higher thermal stress because of it have higher thermal expansion than is what? Steel. So correct answer will be the A for apple is the right answer. There is no thermal stress, no. If you are going to heat and it is fixed, then obviously thermal stress is going to be developed. Yeah, if it is not fixed, then you will not get any thermal stress. But since it is fixed, so obviously you are going to get the thermal stresses. Next question, why a tool were generally more consistent and predictable in multi-point cutting tool compared to single point cutting tool? So what do you mean by multi-point cutting tool? So multi-point, if you talk about multi-point cutting tool, my dear friends, so in multi-point cutting tool, cutting is going to be takes place from the multiple edge, multiple cutting edge will be there. Like if you talk about grinding, milling, that all are multi-point cutting tool. But if you talk about drilling, if you talk about boring or facing, turning, that all comes under the category of single point cutting tool. So the question is that why tool were generally more consistent and predictable in multi-point cutting tool compared to single point? Because in multi-point cutting tool distributed the cutting load over the multiple edge. That's why you are going to get the tool here more consistent. But if you talk about in this one, turning or boring, which is a basically single point cutting tool, you are not going to observe all these here. Next, in multi-plate friction clutch with plate disc, if the axial force remains the same but the number of pair of contact surface increases, the torque capacity will. So multi-plate friction clutch with multiple disc, the axial force remains same but the number of pairs increasing, then the torque. So torque is N mu WR, na? N is what? Effective length, right? If effective number of pairs of plate. So if increases, torque will what? Increases. So correct answer will be D for Delhi. Next question, which of the following centering mechanisms primarily involved in migration of vacancies from neck region to a particular surface is known as what? Diffusion centering. This process is basically known as, that is the process by which you are going to the mechanism involve the primary migration of vacancies from the neck region to a particular surface, and this is known as what? Diffusion centering. Next question, a plank is placed on two support. A plank is placed on two support, one at each end. if person stand at the midpoint of the plank, where will be the greatest reaction force? So plank is a two support, suppose that one is two support is there, and person stand at the midpoint, person is standing here, then obviously both have equal, so both the support you have equal. We can even get to the equation. Let's assume this one is 50, this one is at the 2 meter, this one is at 2 meter, so that will be 25 Newton, that will be 25 Newton easily. So correct answer is what? First is the right answer. Von Mises hanky theory often used in design for ductile material under complex stresses state. It is commonly referred as, this is known as basically distortion energy theory. If you are going to be calculate the deflection, and then you are going to use the deflection energy theory, so it can be what, my dear friends? Deflection energy theory. Next you are going to talk about 88 question. Question is that in the design of riveted joint, what does term efficiency of the joint typically refer? So ratio of maximum load bearing capacity to the weight of rivet? No. Ratio of total strength of all rivet to the strength of plate. Ratio of tensile strength to shear strength of the rivet material. Ratio of the strength of riveted joint to the strength of unriveted plate is basically known as efficiency. This basically term is what? Efficiency. So they are going to use, they are going to ask the efficiency. We can say simply this is called is what? Our efficiency. Which of the following method of forecasting, that is the again question from the machine design. So you can see now various number of question has been taken from the machine design. Sorry, forecasting is from the inventory, but yes, inventory, machining, machine design have lot of question has been asked. So which of the following method of forecasting adjust forecast for both the linear trend and seasonably effect using the thread smoothing parameter? This is called moving average, sectional, Delphi method, Winter exponential method. So this is called is what? Exponential smoothing method. So that question has been taken from the forecasting. Next, if a transportation problem, again that question has been taken from the you can say in your industrial engineering. So the question is that if a transportation problem is solved using Blogger's approximation method (BAM), which of the following criteria primarily influence the initial allocation? You have to allocate now. So the centermost cell in the transportation matrix, the maximum cost in the transportation matrix, the difference between two smallest cost in each rows or column, the demand and supply ratio for each rows and column. So if you talk about VM, so you talk the difference between the two smallest cost in each row or column. So that is the right answer. The positively skewed distribution, is mode always greater than medium? Is medium always equal to mode? The mean always greater than mode? So here if you talk about in positively skewed distribution, the mean is always greater than that of mode. Next, one of the main drawback of a centrifugal clutch, it cannot create a high torque. Yeah, obviously, as I told you, in case of centrifugal clutch, if you see the centrifugal clutch, that one from this like that, no, that shoes are there, and this one like that. Okay, so one of the main drawback, it cannot create a high torque. That's why after attaining certain speed, they are going to transfer the power to that is driver, right? And this one is what? Driven. Which of the following gating system component is most critical than that control the rate of entry of metal mold? So mostly it is going to be controlled by the sprue. So most of the following, which of the following gating system component the most critical that control the rate of entry of the metal into mold? So a pouring basin, gate. So you know, that one is something like a pouring basin, and that is something like a spiral shape. After that, gate is going to be start like that. So this is called is what? A sprue, which is basically making the spiral shape, so that there no should be any aspiration effect. Otherwise we will get the defect of especially porosity lag effect, defect going to be observed over the casting surface. Next, for which of the following material the typically SN curve indicate that the stress at the failure continues to decrease as the number of cycle increases. That is basically, if you go through with the aluminum or Ly, then we can see that stress at a failure continuous decreases to number of cycle as increases. In metal forming process, what is the primary mechanism behind the separate forming? So that is what grain boundary is there. What is grain boundary? So basically there can be coarse, fine, very coarse or very fine grain structures, and the boundary which is going to be separate. Suppose that one, and that one is the coarse grain, let's assume, okay, fine grain, someone is coarse grain. So this is which separate these two. So it is called grain boundary, and grain boundary play a major role here. Now, what does fundamental deviation of the system limit and feet? The position of tolerance zone relation to the basic size. Yes, so the position of tolerance zone will be the relation to the basic size is the right. What is the following factor does not influence the level of safety stock in inventory? Inventory turnover ratio, superior reliability, low time variability. So that is what inventory turnover ratio, which is not going to affect influence that one. A column with both and pinch hinge has a effective length factor K. It have is equal to simply L. Next, what is the primary purpose of using alloying element in powder metallurgy? To improve the flowability of the powder, to enhance the final properties of the synthetic product. So you have to improve the final properties in the powder metallurgy. Main primary purpose of using the alloying element to enhance the final property, whatever property is required, that property you have to enhance. The beaker hardness test, diamond indented have shape, so it have actually a square pyramid shape. Beaker hardness test is going to measure the hardness, where diamond indentator is going to be used, shape will be that. In box Jenkins forecasting model, what does term I stand? I for integrated. I stand for integrated, right? So my dear friends, that all are about the BEL. You have seen very clearly, you are going to see very frequently objective type question is going to ask. Theoretical question is there, not a numerical, very less numerical is there. So you have to focus on that theoretical part only, and then you could be able to do better in BEL. So looking forward, you can join our module, and we will start our preparation. Thank you.